What if we could control Earth's temperature with the push of a button? Injecting particles into the sky or using space mirrors sounds like science fiction, right? But what if this is the future of climate control? Could solar geoengineering be humanity's ultimate climate hack, or are we playing with fire? Let's dive in. Volcanic inspiration, nature's accidental climate control. Before diving into solar geoengineering, let's talk about the event that sparked the idea. In 1991, Mount Pinatubo erupted in the Philippines, releasing over 20 million tons of sulfur dioxide into the atmosphere. This naturally formed sulfate aerosols that reflected sunlight away from Earth, causing a temporary global cooling of about 0.5 degrees Celsius. While this cooling effect was short-lived, lasting for about 1 to 2 years, it showed us the immense power of atmospheric particles in altering the planet's temperature. This volcanic cooling effect inspired scientists to explore how we could potentially replicate this using human-made technology. The key takeaway: we might not need a volcano to cool the Earth, just a few well-timed injections of reflective particles into the stratosphere. Stratospheric aerosol injection, the planetary thermostat. Stratospheric aerosol injection is a highly debated geoengineering technique that mimics the cooling effect of volcanic eruptions, but with a controlled, deliberate approach. The basic premise is simple: inject reflective particles, often sulfur dioxide or similar compounds, into the stratosphere. These particles form aerosols that reflect some of the incoming solar radiation, cooling the Earth. In fact, research suggests that just 5 to 10 million tons of sulfur dioxide injected into the stratosphere could potentially lower the global temperature by about 1 degree Celsius. The potential for this technique to offset global warming, at least in the short term, is why it's being seriously considered. However, the side effects could be significant, including changes to rainfall patterns, disruptions in the ozone layer, and potential risks to global food security. It's also not a permanent fix. It simply delays the inevitable need for long-term climate action. Shocking fact: the Pinatubo effect. The cooling effect from the Mount Pinatubo eruption serves as a powerful example of how geoengineering could theoretically work. The eruption released large amounts of sulfur dioxide and ash into the stratosphere, where it formed a veil of aerosols that reflected sunlight. This cooling effect lasted about 2 years, during which global temperatures dropped by 0.5 degrees Celsius. To put this into perspective, this drop was enough to slow the rate of global warming temporarily, but the cooling effect was short-lived. Research published in journals like Nature and Geophysical Research Letters highlighted how natural events like these could be leveraged for geoengineering. However, scientists caution that relying on such methods is not sustainable. A similar process artificially introduced could also have unpredictable effects, as we would be controlling a system that is inherently volatile and complex. Controversial methods. Are we playing God? Marine cloud brightening. One of the more down-to-earth geoengineering techniques is marine cloud brightening, where seawater is sprayed into low-lying clouds to make them reflect more sunlight. The idea is that by brightening the clouds, we can increase their albedo, the amount of sunlight they reflect back into space. In studies funded by the UK's National Environmental Research Council, scientists have estimated that brightening clouds over just 2% of the world's oceans could cool the Earth by up to 0.2 degrees Celsius. This sounds promising, but there are many unknowns, particularly concerning its impact on marine ecosystems. For example, the release of salt could affect the balance of nutrients in the ocean, disrupting marine life, especially phytoplankton, which are crucial for carbon absorption and the food chain. Cirrus cloud thinning. Another approach under consideration is cirrus cloud thinning. Cirrus clouds, which form high in the atmosphere, have been found to trap heat rather than reflect sunlight, thus contributing to warming. By thinning these clouds, scientists hope to reduce their heat-trapping effect and allow more sunlight to escape into space. Research by NASA's Jet Propulsion Laboratory has shown that cirrus clouds are responsible for a significant portion of Earth's greenhouse effect. If we can find a way to thin them without causing adverse weather disruptions, this could help moderate global temperatures. But thinning these clouds is no easy task. It requires precise control over atmospheric conditions and could lead to unforeseen consequences, such as changes in precipitation patterns or even the intensification of storms. Theoretical space mirrors. Now, here's where things get truly wild. Space mirrors. The idea of using giant mirrors or reflective satellites in orbit to reflect sunlight away from Earth sounds like something from a space-age fantasy novel. However, some researchers believe that this might be a viable way to directly manage global temperatures. A study by the University of Arizona suggested that placing reflective mirrors in space could be used to regulate Earth's temperature by reflecting a small portion of the sunlight before it even hits our atmosphere. The concept involves launching multiple mirrors into space to form a large-scale solar shield. While the potential is enormous, this technology is still theoretical and faces numerous challenges. Besides the cost of launching such large structures into space, there's also the risk of creating space debris or altering the orbits of other satellites. Provocative questions to spark debate. The science behind geoengineering may seem promising, but it raises serious ethical and practical questions. And these questions aren't just academic, they could have real-world consequences. So, who gets to control Earth's temperature? Will it be a global effort, or will countries with the most power and resources dictate the planet's climate? If a country like the United States or China decided to implement geoengineering without global consensus, it could lead to geopolitical tensions and even conflicts over control of the atmosphere. Moreover, what happens if these technologies go wrong? AI, for example, could lead to regional disruptions in rainfall, causing droughts in some areas while increasing flooding in others. There's also the possibility of long-term, unforeseen effects on ecosystems, from forests to coral reefs. And what happens if we stop? If the world relies on geoengineering for decades and then suddenly halts the process, we could experience rapid warming, known as termination shock, leading to even more severe climate consequences. Are we playing God with planetary systems, or are we simply trying to survive? Critical ethical dilemmas. As we explore the potential benefits of geoengineering, we must also acknowledge the serious risks and ethical dilemmas. These interventions could cause unintended consequences, such as altering global weather patterns or disturbing ecosystems in ways we can't predict. For example, research published in Science suggested that while AI could lower global temperatures, it might also disrupt the monsoon seasons in Asia, potentially threatening food security for millions of people. There's also the issue of geopolitical tensions. If one country or group of nations decides to deploy geoengineering, it could spark international conflicts. A unilateral decision to alter the climate could affect rainfall patterns, agricultural output, or water availability in other parts of the world, leading to disputes over who controls this new form of climate management. Furthermore, geoengineering could worsen ecological unpredictability. While some species may adapt to the new climate conditions, others may not, potentially leading to mass extinctions or the collapse of ecosystems that we depend on. Not a permanent solution. Solar geoengineering is a temporary fix, not a permanent solution to climate change. While it may buy us some time, it does not address the root causes of climate change, such as carbon emissions and deforestation. It could even create a false sense of security, delaying necessary global actions to reduce greenhouse gas emissions and transition to sustainable energy sources. In fact, solar geoengineering, while promising, remains controversial because it could distract from real solutions, such as green energy innovations and reducing carbon footprints. Until the world agrees on how to proceed, geoengineering will likely remain a tool in the toolbox, one that should be used with caution, not as a silver bullet. So, what do you think? Should we take the risk with solar geoengineering, or is it too dangerous to mess with Mother Nature? Drop your thoughts in the comments below. We'd love to hear what you think. If you found this video fascinating, don't forget to hit that like button and subscribe for more videos.